Hello, this is Steve from SDRplay. Today I'm going to attempt to answer a question we're often asked, namely, how much PC do I need to run SDRuno and an RSP? And kind of building on what we discussed there, I'll talk about building a low-cost, self-contained SDR radio system. So first up, the most commonly asked question, what PC specs do I need? I'll give you a short answer to that question so that you can finish the video and get back to your everyday life. But then, if you're interested, I'm going to go into some of the factors that affect the performance you'll be able to achieve, and then talk about building a somewhat customized, low-cost solution to implement an SDR radio system. So how much do I need? If ever a question begged the answer, it depends, it's got to be this one. So I'm just going to go ahead and make some recommendations that I think would be pretty good for a general purpose PC or laptop implementation. If it has a Core i3 processor or equivalent, 4 gig of RAM and a 500 gig hard drive, you're probably going to be able to run an RSP at up to its full sample rate of 10 megahertz. And probably run some other applications on there as well without much difficulty. If you have a bit more money to burn, a better system would be Core i5 based, 8 gig of RAM, because as we all know, more RAM is good. And if you can go for it, my personal preference is to go with a SSD, a solid state drive. I found they're much more snappy in operation and well worth a few dollars extra. But one of the things I want to mention here is you can get by with a whole lot less than that. And primarily here I'm considering talking about the Windows platform, but some of the same arguments apply to other platforms, including, for example, the Raspberry Pi. So that's the short answer, and if you want to stay with me, let's look at a somewhat longer answer. One of the key things that affects what you're going to run this on is the maximum sample rate that you require from the RSP. The hardware is capable of running up to 10 megahertz, and if you want to run at that full rate, then that will require a fairly capable CPU. That's why, for example, although it's possible to run an RSP with a Raspberry Pi, you'll be lucky to get 1 megahertz sample rates out of it. Indeed, in most cases, probably closer to 500 kilohertz. So that in turn affects the CPU speed. And that's the primary trade-off right there between sample rate and CPU speed. The other thing to consider is USB peripherals in the system. An RSP running at a 10 megahertz data rate will consume pretty much the entire bandwidth of a USB 2.0 controller. So if you plan on running other USB peripherals that require a lot of bandwidth, video cameras, other SDRs for example, then you want to make sure that your system has a separate USB controller so that you can share the bandwidth and not be restricted by a bottleneck over the USB bus. The next one is how much RAM do you have? And although SDRuno itself doesn't necessarily require a whole lot of RAM, if you're running a lot of other applications concurrently, that can start to consume vast amounts of RAM, and if you end up swapping back and forth between RAM and a hard drive, that will really slow down operations. And another key thing, especially in Windows land, is background processes. Windows has an almost unbelievable number of background tasks running all the time, and if you ever open up Task Manager, you'll get some insight into that. And that's something we might consider when we're later on trying to build our own optimized system. So what I want to introduce to you here is a concept of PC versus dedicated appliance. And some of you may remember the picture on the left. I'm sure a lot of you have been around a while, as have I. And we remember the advent of PC systems. And our mentality has always been to get the biggest, best, latest, and try and run absolutely everything we can on the one PC. But we also are aware that there is a tendency going on in our everyday life to put embedded processors in just about everything. I just recently bought a new washer and dryer, and I know for a fact there's at least one microcontroller in each of them, and pretty much everything you buy in your house these days will have dedicated embedded processors to which are designed to just optimize the one task they have at hand. So my question is, what if we take that same approach to an SDR radio system? I'm not necessarily talking about dedicated hardware, but what if we take some hardware and dedicate it application-wise to just SDR applications? This is my first system. This was an Asus netbook. Has a very modest processor, Z3735. Only had 2 gig of RAM, only 32 gig of main storage, but it has an 11-inch screen. It's lightweight, very portable, and it works just fine for sample rates up to about 4 megahertz using the RSP 1A. I bought it on sale at one of the office supply stores for about $150. This was a few years back, and it makes a very competent SDR solution. Now, what did I learn from getting that, however? First up, as I mentioned, the performance was acceptable up to about 4 megahertz. But when running or opening other applications, even just opening a web browser for example, it can cause disruptions to the signal. I also mentioned before, Windows runs many background processes, especially Windows Update, which can cause performance hiccups. So turning off some of those background processes can really help optimize performance in an SDR environment. But with all that having been said, it does make a very good, very convenient portable system, or it's a small footprint that you can set up next to your rig and use it as a PAN adapter, or you could just add one to your shack as a useful general coverage receiver, and for $150 you haven't broken the bank. So inspired by that, I went on to try and develop a custom SDR system, and I guess that may be just the ham in me, but we do tend to like to tinker around and make things and try and do things better. And initially I wanted to develop something that was portable, that I could take to shows, club meetings and so on. And I was also keen to see what sort of performance I could get out of the MiniPCs that were becoming available with a pretty low price tag. So I started off by trying to build everything into a clear plastic box, because I thought that might be kind of cool. And you can see that picture at the bottom. You see a MiniPC on the left, the RSP 1A on the right, and that's a little speaker in between the two. And I wasn't overly impressed with it, and at the end of the day I was kind of inspired by seeing some of the comments about the MiniPCs, that you could get a VESA mount for them to mount them to the back of a monitor. And that kind of got me thinking. It's like, well, what if I mount one of these MiniPCs to the back of the monitor? Can I mount an RSP there as well? And as you can see on the right, that's exactly what I did. I picked up a 15-inch monitor. I made myself a little custom mounting bracket. You can see that in the middle with the 4 screw heads. And on one side I mounted the RSP 1A, and on the other I mounted a MiniPC. And in the top picture you can see there I am running SDRuno. I also added a Bluetooth keyboard and mouse to keep the wiring rat's nest down to a maximum. And coincidentally, along the way, I was able to find a monitor that ran off 12 volts. And with that running off 12 volts and the MiniPC also running off 12 volts, I was able to drive the whole system from a single power supply. And that in turn would make it very useful if you wanted to put it in an RV, or take it somewhere and run it off just a car battery supply, which of course would be much quieter than using any kind of switching power supply. So if you're going to embark in this direction, some of the things you want to take great or pay attention to is the CPU usage and the processes that are running. And on the left here you see I'm running about 50% on an Intel Atom. It's a Z8350 in the MiniPC. Again, it's running reasonably happily up to about 4 megahertz sample rate. In fact, my experience is when you're running FM broadcast stations, that seems to take the biggest toll on the CPU, and you start to get audio dropouts sooner on those FM broadcast stations than you would, say, if you were working the HF bands. So over on the right we see some of the processes and services that are running, and you'll see there in the pictures I'm now running the SDRuno and the new API service, which was introduced with Uno version 1.24. And this is where you see things cropping up like various processes involved with Windows Update. And my recommendation is to go into System Settings and, if possible, just turn off Windows Update. And then maybe once a month go in and install all the updates, let the thing install overnight, and then disable it again so that you can have uninterrupted use from your RSP thereafter. So what I tried to answer was, what does it take to run SDRuno? And in practice it will run on most newer computer hardware. But for dedicated applications, for example, if you just want the SDR functionality, or maybe you just want a PC dedicated for ham radio use in the shack, you can get away with much lower spec devices. In fact, a perfectly viable approach is, if you have some super duper all singing all dancing new laptop or PC that has the latest graphics and you're playing games and doing all that good stuff, take your old device and check it out as a dedicated ham radio computer. You can roll your own system to meet specific needs of the user, and I should point out at this point that whereas my original netbook cost me $150, by the time I bought the MiniPC, the monitor, and the keyboard and mouse, I probably spent more than $200 on my latest project, although I am very happy with the results. And depending on what you decide you need for your system, there is a wide range of low-cost MiniPCs, or as Intel calls them, NUCs, or Next Unit of Computing, which are basically very small form-factor PCs, and with a big variety of processors, ranging from simple Atom processors all the way up to i7 cores and so on. So you take your pick of what you want to do, but it's certainly perfectly viable to roll up a system that's best suited for what you want to do with it in your shack. Anyway, that's about it for today. I hope there was something useful in here for you. As always, please come to SDRplay.com to look for the latest information on our products. And thank you for watching. 73.